Hello everyone, and welcome to Math 111. This is the first lecture to our lecture series. Before I start the topic of linear equations, discuss the information provided on the blackboard. You have access to the syllabus, spacing guide, and the link to Alex to do your homework. Homeworks are due every Sunday, so you have a week to finish your homeworks. And I will be providing lecture videos on daily basis. I will try to do as many as possible. This way you have more time to do your homework. And there is no mandatory Zoom meeting. Zoom meetings are only used for office hours. If you have any questions, let me know the day before, let's say a couple of hours before the meeting. This way I can make sure that there's enough time for me to answer your questions during the Zoom meeting. Okay, I will create a link for the Zoom meeting on Blackboard as well. If you have any question, send me emails. Do not wait till the last moment. This way, we can be in contact with each other more often. Okay, with all that being said, let's start the first topic of our class, linear equation. What is a linear equation? A linear equation has the form of ax plus b. Ax plus b is the form of a linear equation. If we say it's an equation, it means there should be an equality. On the other side, it could be zero, it could be constant, so there should be an equal sign when you're discussing equations. A and B, they're both real numbers. So A is a real number, B is a real number. X is your variable. It could be AY plus B. It's possible to write this equal to 0. Still, Y is a variable, A and B are constant. So in this case, a linear equation in one variable x has the form of ax plus b equal to 0. A and B, again, real numbers. What is a real number? Real numbers could be 1, 2, 3, -2, -5, all those integers. Decimal values, 3.2, 5.7, 0.5, whatever decimal number is, positive, negative, it could be 0. Square root of 3, that's a decimal number as well. You can think about it as 1.71 and so on. Square root of 2, this is a real number. You can write the decimal form of it. The only difference is the other decimal values, they end up at somewhere. Square root of 3 and square root of 2, these are irrational numbers. They will go on forever. So you're not writing the exact number, you're approximate. Pi is another real number. 1/3, that's a number, real number. Negative fractions. 1 divided by square root of 2. These are all constants. As long as you have a constant, that's a real number. Square root of 3 divided by pi, even though it doesn't look that nice, but it's still a real number. So these could be coefficients for a and b. These can be those numbers. A could be square root of 3 over pi, for example. B could be 1 over root 2. Still, it will provide you a linear equation. The important thing is that the variable that you have has an exponent 1. So if you have x, a plus b equal to 0, x must have exponent 1, not more than that. If it's squared, then it's not linear. It cannot be in the denominator. You cannot have a divided by x, but it's not a linear equation. This would be a rational equation. So the format is always ax plus b. There are certain examples of linear equations and nonlinear equations. Whatever is not linear, we consider as a nonlinear equation. Here, let's look at a couple of examples. For example, 2x plus 3 equal to 0. 2 is your a, you have ax plus 3 is your b equal to 0. This is definitely a linear equation. How about 1 minus 2x equal to 0? The arrangement does not really matter. You can rewrite this as negative 2x plus 1 equal to 0. The positive 1, the negative 2x plus 1 equal to 0. A is -2, B is +1. This is still a linear equation. How about x equal to 0? X equal to 0, you can think about it as 1x plus 0 equal to 0. 1 is your A, B is 0, and you have ax plus b, so therefore equal to 0. Therefore, this is a linear equation. As I said, square root of 5 is a constant, so this could be a. Square root of pi is another constant, real number, b. This is a linear equation. Square root of 5x plus square root of pi equal to 0. But make sure that this x is not underneath the radical, outside multiply. How about 2y squared minus 3? We have exponent, y squared, definitely another linear equation. Y minus x equal to 0, we have two variables. It is a linear equation, but it's in two variables. We haven't discussed this, so we cannot consider this linear equation in one variable. Fraction with x in the denominator, definitely not a linear equation. How about x third plus 1? You can think about x third plus 1 as 1/3 times x plus 1 equals 0. X over 3 is the same as 1/3 times x. These two are equal to each other. So therefore, I have a x plus b equal to 0. This must be a linear equation. How about x minus 1? This is not a linear equation because there is no equality. There is no equality. If there is no equality, there is no equation. 2x plus 3 minus 0, same mistake. There is no equal sign. If this was equal to 0, then this would be a linear equation. If there is no equality, it's not an equation to discuss. How about 1.5x minus 3.2? This is again linear equation. 1.5 is a constant, negative 3.2 is another constant. You have ax plus b equal to 0. Even though this is negative, you can put it next to the 3.2 and say b is negative 3.2. This is linear equation. So all the linear equations have the form of ax plus b in general. Okay, so let's discuss the property of equality. This is something that in general should make sense in real life. This is what you deal with is equality between two persons. You can think as A and B are two people. If they have the same amount of money, what you can do is if you give them an extra money C. So if you look at this equation, A plus C equals B plus C. If A and B were originally equal, you can add C to both sides. They still have the equality. So it means that if two persons have initially a certain amount of money, you can add $10 to each person. They still are equal to each other in the sense they have the same amount of money. If you take away $10 from each, they still have the same amount of money. So the equality is in the sense that if you start with an equal statement, if you start with a true statement, then whatever you do on one side of the equality, if you do exactly the same thing on the other side, you still the equality still holds true. It's something that you do in real life. If you have two kids, if you want to treat them equally, you will do exactly the same thing for each one. So if you give one $10, the other one be treated equally, you need to give $10. So if you have an equality, whatever you do on the left side of the equal sign, you should do exactly the same thing on the right side of the equal sign to hold equal. If you multiply a constant on the left side, you multiply the same constant on the right side to hold the equality as a true statement. Same with the division. Just make sure that when you divide, you cannot divide by 0. If you divide by 0, you have an undefined value. You cannot have 2 divided by 0. This is undefined. The same as 1 divided by 0. These are undefined values. You never divide by 0. Even 0 over 0, still undefined. Do not make this mistake. You can never divide by 0. On the other side, 0 divided by 1 is well defined and it is 0. This is important that do not make this mistake. While we're discussing this, we will use this idea to solve equations, specifically linear equations, and later on we'll use it for other types of equations. So linear equations in one variable. How do we solve? The textbook will provide you like 6 or 7 steps. I combined all these steps into 3. Simplify the equation is your first step. This means if you have distribution, you have like terms, you combine like terms. Combine like terms. What else? If you have fraction, you want to get rid of, so simplify fraction. We will do examples just to make sure. With this simplification, basically doing all these steps, the textbook will separate, says do this first, do the other one. It doesn't really matter as long as you do it correct. You can combine them and together, do it at the same time. Second step would be to use the equality properties to solve the equation. Solve for a certain variable. If you have one variable, you're looking for that variable. What was the equality property? However you treat on one side of the equality, you do exactly on the other side. So if you're adding a number to one side, you should add the same number on the other side. If you're taking away a number, you should take away the same number. Multiplying and division, same. And finally, by using the equality, you can find the variable by itself. So you will find out something like x equals to 5, for example. After you get to this point, you check this number 5 into your original solution. See if it is really the solution to your equation or not. So the last step is to check your solution. And where do you check it? You check it in the original equation. It should satisfy the original equation. Because later on we'll discuss that when you square an equation, it might affect the equation a bit. Since if you square a negative number, the outcome becomes positive. So it's important that you check your solution always. Here is an example. Let me change the color here. Okay. Let's solve this equation. 2 times x minus 3 plus 5 times x minus 2 minus x minus 1 equal to negative. First step is always get rid of the parentheses. How do you do that? You do it by distributing. This coefficient 2 multiplied to both sides. Coefficient 5 is that parentheses multiplied to both sides. This negative is a negative 1. You have to distribute it to each side. So if I do that, 2 times x is 2x times negative 3, x. 5 times x, 5x. 5 times 2, 10. Negative times x is minus x. Negative times negative 1 plus 1. And on the other side I have minus. So far we're not done with the simplifying. This is just distributing. Simplify means combine like terms. What do I have is 2x, 5x, and negative x. 2x and 5x, this is 7x, minus x, x. I have negative 6 plus 10, that is positive 4, plus 1, plus 5, equal to negative. So now I've simplified the equation. What do? I use the equality property. What does it mean? That means whatever you do on one side, you should do exactly the same on the other. If I subtract the 5 from left side, I should subtract the 5 from right side as well. By doing that, I'm going to isolate the variable x. This is always what you do. You isolate the variable. Get rid of every other term. So I will get rid of the constant, negative 5 on the right and the positive 5 on the left side. So what do I get is 6x equals, these two will cancel out. Negative 1 minus 5 is negative 6. One more step, isolate the x. How do I do that? I divide both sides by 6. The equality property. If I do that, these two will cancel out. And what do I get is x equals negative 6 divided by 6, negative 1. This is a potential solution. It doesn't mean that it is always a solution, but if this equation has a solution, this is the potential solution for that equation. You can check your solution by replacing it back into the equation. If I replace it back into the equation, which equation I'll replace it? Into the original one. 2 times -1. Every time I see x, I'll replace -1. -1 minus 3 plus 5 times -1 plus 2 minus -1 minus 1. I want to see if it is true if I end up with -1 on the right side. If I calculate, -1 minus 3 is -4. This is -4. -1 plus 2 is 1. -1 minus 1 is -2. 2 times -4 minus 8 plus 5 times 1, 5. Negative times -2 plus 2. -5 plus 2 plus 2. Sorry, -5 plus 5 plus 2. This is true. This is equal to -1. So this means that I can accept this as a solution. This is a true solution. You can write the solution set. This is something that the textbook uses. I'm okay with you just drawing a box around it. But just to understand solution set, the notation. These brackets, and you write the number in there. The -1 means -1 is the number that satisfies this original equation. Okay, let's try another example. X over 2 minus 1 equals to 2. First step, always with dealing with fraction, is try to get rid of the fraction. If there is distributing, you should distribute. This example, there is only fraction. And you look at the denominator and say, okay, the denominator is 2. How do I get rid of that? I can multiply a constant to both sides. I can multiply 2. By doing that, I can cancel out these 2. But this 2 is multiplied to the whole thing on the left side, as well as on the right side, you should multiply it. So whatever you multiply on the left side, you should do it exactly the same on the right side. So let's distribute 2 times x over 2. I'll get 2x over 2. Do not multiply to the denominator. 2 times x half means you can put the denominator 1 and say 2 times x is 2x. 1 times 2 is 2. If you multiply it to both, that's a big mistake. You're rescaling both numerator and denominator. You do not multiply. So this will not make that mistake. Okay. So 2 times x half is 2x divided by 2 times -1 is minus 2. Minus 2. 2 times 2, 4. Here is the good thing about multiplying that constant. These two can cancel out now. What do I have is x minus 2, 4. I simplified the equation to a simple linear equation. No fraction. Makes the work much easier. This is the equality property. Add constant 2 goes to both sides. What you get is x equals, cancel out, 4 and 2, 6. Is it the solution? I really don't know. We have to check. So how do we check? We go back to the original equation, the one written in red, not the coefficient 2. So I replace 6 there. 6 over 2 minus 1. What does that end up? 6 divided by 2 is 3 minus 1. And it satisfies this equation. This is a true statement. 3 minus 1 equals 2. Therefore, our solution set is 6. Okay, let's do maybe one more complicated. It follows the same mentality. First step is always you look at the equation, say, okay, can I get rid of the fraction? Makes it easier without the fraction. And you should know something about least common divisor, LCD. Least common divisor is what number is divisor of all these. So what number divides 2, 4, 3? It could be something like 120. it divides all these numbers. But normally we'll look at the smaller one because we don't want to multiply a huge number. For example, 12, LCD of 2, 4, and 3. 12, because 12 divided by 2 is 6, 12 divided by 4 is 3, 12 divided by 3 is 4. So 12, you can divide all these numbers into. So what do? We multiply 12 both sides. Make sure that you use parentheses, so you know that 12 this multiplies to the whole thing. 12 times the first one, and change the color this way. Now what do? 12 times the first equation is 12 times, I'm going to write it as y plus 5 divided by 2, and use parentheses, minus 12 times that, this one. You can distribute to y and 5 at the same time, but I'm going to do it in 2 steps. 12 times next one, 12 times y minus 2 divided by 4 equals 12 times that fraction as well as 12 times 12 times y plus 7 divided by 3 and 12 times 1. Okay. You can distribute it first, or you can simplify first. Maybe simplifying first is better. Here. 12 divided by 2 simply 6, so I can consider 60. 6 times y plus 5. 12 divided by 4 is simply 3. 3 times 1 minus 12 divided by 3 is 4. By simplifying it first makes the work easy, so I do not need to then divide. 6 times y plus 5 is 6 times y. 6 times 5, distribute each one. 30. 3 times y minus, sorry, do not forget the negative sign. The negative sign is there. Negative 3 times y is negative 3y. Negative 3 times negative 2 plus 6. You should consider this negative with a 3. On the other side, we have 4 times y, 4y, 4 times 7, 8, plus 12. If instead of using 12, if you would have used 120, again, you can solve the equation by that. Multiplying 120, these numbers would be huge. The work would be much more. So now, what can I do? I'm going to combine like terms. 6y and negative 3y, simplify to 3y. 30 plus 6, positive 36. On the other side, I have 4y plus 28 and 12, 40. Okay, so now continue here. What do? Try to use the equality property. So I'll subtract 4y, sorry. I'll subtract 4y from both sides. You can subtract 3y if you want, doesn't really matter. And at the same time, you can do it in 2 steps, or you can do it at the same time. I can get rid of the 36 as well. I can subtract 36 on both sides. Why am I doing that? I'm trying to isolate variable y. You can do it in 2 steps, you can do it in 1 step, doesn't matter. So by subtracting 36, I cancel out these two. By subtracting 4y, I can cancel out those two. 3y minus 4y, negative 1y. Left side is only left with negative 1y. Right side, 40 minus 36, positive 4. What did I do? I isolated the y by itself. There is some coefficient negative 1 in front, which I can use the properties, equality properties, and divide both sides by negative 1. You can multiply both sides by negative 1, doesn't really matter. By doing this, We'll cancel out. I get y equals -4. Is the solution? You don't know. You have to check it back into the original equation. The original equation, let's try -4. We have -4 plus 5 divided by 2 minus -4 minus 2 divided by 4. Sorry. And equals y plus, there's no y. Y is -4, so -4 plus 7 divided by 3 plus 1. Times 2 whole square. So by doing this, we can say -4 plus 5 is 1, so I have 1/2 minus -4 minus 2 is -6 divided by 4. You know, have -6 over 4. -4 plus 7 is 3 divided by 3 plus 1. -6 over 4 could be simplified to -3 over 2. So negative and negative becomes positive. So you have plus 3/2. Right side, 3 over 3 plus 1 is 2. What is 1/2 plus 3/2? It is 4/2. This is equal to 4/2. 4/2 equals to 2. So therefore, yes, our solution set is negative. Okay. I'm going to stop here and continue